Thank you for joining us today to learn more about QDrive, Haskel's new state-of-the-art electro-servo-driven gas compressor. Before we get started, I'd like to go over a few general points. We will have a Q&A session at the end of the presentation. For now, attendee mics are muted. They'll be muted throughout the presentation. You can type your questions in the Q&A area. The Q&A icon is located at the bottom center of your screen. We will answer all questions asked, addressing as many as possible during this live session, and then responding directly to the inquirer afterward for those questions we couldn't get to during the presentation. We will also publish and share an FAQ sheet in a post-webinar follow-up email, and we'll share the webinar link so that you can view it afterward and share it. Now let's look at our agenda for today, and I'll introduce our speakers and panelists. First, we'll start with our history of innovation that began with the development of the first hydraulically driven gas booster. Then we'll move into our latest innovation and the most technologically advanced gas compressor in the industry, QDrive. We'll go over its working principles and features, including the servo motor and the gas sections, and you'll see a tour of the system. And then we'll talk about what makes QDrive so revolutionary by going over its features and what they bring to the table. We will provide a couple application overviews from field beta testing, and then we'll end with the Q&A. Okay, let's meet the team of experts who are bringing this together. In the order in which they are presenting today, we have Mr. Dave Gordon, our Global Product Manager. Mr. Richard Gilberg, R&D Controls and Mechanical Engineer. And Mr. Scott Sopko, North America QDrive Sales Manager. We also have our group of panelists who will help answer your questions at the end of the presentation. We have Mr. Jason Carmen, Commercial Director, and Mark Leapins, America's Director of Sales. So let's get started. Without further ado, I present Mr. David Gordon.
Thanks, Irma. I'm very excited to be here today to talk about Haskel's latest innovation in gas booster compression technology. But before we jump into what our new technology, we thought we'd give you a little history on where Haskel's been in the past and what's brought us to where we are today. In 1954, Haskel was the first company to develop a hydraulically driven gas booster that used a non-lubricated, that is a dry seal in the gas section of the booster. That dry seal allowed us to maintain a much higher level of gas cleanliness than had been recognized before in other technologies. These new hydraulically driven boosters were used primarily by NASA for boosting nitrogen and helium up to 10,000 psi. Over the last several years, Haskel has had a number of design updates that have been incorporated in these hydraulically driven boosters. And the latest design is called the H-Drive, and that's what Haskel is now selling today. The H-Drive is capable of generating pressures to greater than 15,000 psi with very high flow rates, and it can handle most industrial gases, including hydrogen. This right here is just kind of an example of a Haskel hydraulically driven gas booster. It's a pretty simple unit. The middle of it has a hydraulic drive. High pressure hydraulic oil is pumped into this, in this case here, is pumped into the left side of the drive, causing this piston to shift over to the right. When that happens, the spent oil is pushed out back into the reservoir of the hydraulic system. As that happens, it also pushes this piston over here into the gas section over here, compressing this gas to, like I said, it could be as high as 15 or so thousand psi and out into the process downstream. On the left side, as the right piston moves to the right, this piston is also moving to the right, which is drawing in fresh gas from the source right here. Then when the system reverses, the high pressure oil is pushing on this side here, causing the system to shift to the left. We're now compressing this gas on the left side right here and drawing in fresh gas on the right side for the next compression cycle. This picture here is of a typical hydraulically driven gas booster system. They all look a little bit different, but they all have a certain number of components in common in the systems. They all have a hydraulic motor and pump. They all have a reservoir in them that's going to contain at least 50 or so gallons of oil, if not more, a control. there's going to be a frame that holds it all together, a containment on the bottom, which is very important, which will capture any oil that gets spilled to keep it from getting into the local environment. There's going to be a variety of controls and valves, heat exchangers for heating, cooling both the oil and the gas, as well as the hydraulically driven gas booster itself. So, as we've discussed, the new QDrive uses an electric servo motor, and I've had a number of people ask me, what is an electric servo motor? An electric servo motor is a motor that has an interface that allows an operator to control the motor, has a PLC or a computer controller, has a signal amplifier, has an encoder on the motor, and a drive screw. Haskel's electric servo drive motor incorporates a permanent magnet synchronous motor. The motor speed is controlled by varying the power frequency using a variable frequency drive, and the stop position is controlled by a single pulse by controlling the duration of the single pulses. Here's a schematic that shows a typical servo type drive. We have the human interface right there. Then there's the controller, and then a signal amplifier that's both sending signals to the power and signals to the motor. And then there's an encoder here where the signal is going back to the signal amplifier to give position reports to the signal amplifier and the control. Then as the motor turns, it's turning a drive screw that's actually doing the work that needs to be done. So the new QDrive is an electric servo-driven gas booster. So what's an electric servo-driven gas booster? It's a booster that uses the same compression technology that we used on the hydraulically driven gas boosters that we just talked about, but instead of using the hydraulic drive, it uses a servo motor. This is kind of a drawing of what it looks like. In the middle, we have the servo motor itself, which is turning a ball screw. That ball screw will then move to the left or to the right. As in this case here, as it moves to the right, it will compress the gas using the same compression technology that we use on the hydraulically driven gas boosters. And then as it shifts to the left, it'll compress the gas over here on the left side. There's a number of advantages to the use of an electric servo drive on the gas booster. The servo motor is much more efficient than traditional motors, has much lower cooling requirements. It can start under load. There's no requirement to start and to use a bypass loop, and you can start and stop at any time. And while the system is not running, there's virtually no power consumption. The only power being consumed is the power to drive the control itself. It's kind of demonstrated its efficiency on this chart here to the right. This blue line represents the efficiency of the system at various duty cycles using the servo drive motor, and you can see it doesn't really drop off too much regardless of the duty cycle. While the hydraulically driven booster, the lower the duty cycle, the much more loss of efficiency we have, and that's because and this applies to many compression technologies. Most of the system components have to keep working even when they're not producing pressure. They still have to keep working using energy, while the QDrive or the servo drive does not have to keep using energy while it's not working. Other advantages of the electric servo drive booster are that it's much more environmentally friendly. There's no high pressure hydraulic oil. The servo drive gas booster holds 20 liters of low pressure oil that's used for lubrication, and it operates at less than 30 psi pressure. It's quiet. The maximum output for the whole system is less than 77 decibels, and it has a small footprint. It can also be used to handle high purity gases and has special separation for that, and we'll have more details on that in a few minutes. The control on the servo system gives us a very high degree of controllability. We can change our cycle rates. We can run it very fast or very slow, depending on the specific application needs. There's over 30 sensors in the system measuring forces, temperatures, and pressures. And the control, while it's monitoring all those sensors, if it sees something starting to operate slightly outside of the normal operating environment or window, it will adjust the operation of the system so the system can keep running, but just make adjustments to try to reduce the problem. For example, if the temperature in our gas section starts to get a little bit too warm, instead of shutting the system off or damaging something, it will just slow it down to allow the heat to dissipate. And then as that heat dissipates, it will speed it back up again. Also, the servo drive allows, because of its precise position control, it allows us to have an absolute minimal amount of unswept volume, giving us the highest level of gas compression efficiency that's possible. Also, the control will alert operators when service is due, or if there's anything that's not operating quite the way it should be. And then the actual maintenance of the QDrive has much lower requirements than typical compressors that do similar types of pressures and flows.
Thanks, Dave. Now we're going to see a tour of QDrive, compliments of Richard.
Hello, my name is Richard Gilbert. I'm a control engineer at Haskel. We're down here in Haskel's Research and Development Lab in Burbank, and I want to give you a quick tour of our newest technology in gas boosting. This is the QDrive. High efficiency, brought to you by the permanent magnet technology. First off, let's just take a look at the small footprint. This is a standalone system. The idea is plug and play. The footprint is 8 foot by 3 feet deep. What you'll have to do here once this thing gets shipped to you is you'll be required to supply 2 things to this: coolant and power. So let's just take a walk through that. Over here we have our 480 volt drop, and we have our chiller outside. That's the chiller is connected to the bulkhead in the back. Every unit will be shipped out with this quick disconnect. So all you have to do is bring power to this, plug her in, turn her on. While this is powering up, let me just pop this cover off here and we'll take a look at the lubrication circuit. The servo drive is lubricated with a synthetic gear oil, and that's also provides cooling. That is going through this lubrication circuit, powered by this 3/4 horse motor. The oil is cooled down at this plated heat exchanger, and the coolant is diverted by these smart solenoids, either bypassing the coolant to go directly to the gas sections or keeping the oil viscosity at its ideal temp. The oil at the ideal temp. The oil also goes through these 2 filters, and during every 2,000 hours of service, it will replace the oil filters and replace the oil. Up top here, let's just go through the gas sections. Right now we're looking at a single stage double acting gas booster. This is the QGD 90. Again, here's your cooling circuit going through the cooling jackets. Your servo drive. We have our distance piece gas section. The distance piece ensures there is no oil getting into your gas section. The oil is operating at lower than 30 psi. This is the heat exchanger. We can use this as a pre-chiller. We can use it as an after chiller in a 2-stage configuration where we take the first stage, we'll store it inside a interstage vessel. That gets cooled down by the heat exchanger as well before it enters your second stage and then downstream to your application. So let's just turn this thing on. Each system does come equipped with the Allen Bradley PLC product, Rockwell Automation. Let me get this other cover out too. There's a few levels of security in here, management, technician, service. I'm going to log in with the highest level of security. This is where you can set up the parameters for your application, and I'll run through that quickly here. So we're logging into the home screen. For now, I'm just going to put it in compressor mode. I'm going to set my target pressure to about 3,000 psi, and I'm going to set my deadband at 2,400 psi. It's going to kick back on. So we're going to kick her on. Right now, in your first, after every power cycle, it's going to go through its initialization phase. It's actually homing, touching the piston ends to each end cap. with the accuracy of the encoder and the servo drive, we can virtually, we can say there's no MSOF volume at the end here. That's where we get our high efficiency as well. So right now I'm going 10 cycles a minute. You do have rate control. I'm going to kick it on to 50 cycles a minute. Right now it's going to try to reach 3,000 PSI. Once it does, it's going to kick off, and as something's getting depleted downstream, it's going to wait till it hits that lower dead band and kick back on. It can do this all day long, 24 hours a day, 7 days a week. I also want to just demonstrate for you the quietness here. I have a dB meter. I'm going to set this pressure up so it's just going to run like a closed loop, like an extraction process. So this thing's just going to run. Right now I have my dB meter. I'm talking right now. It's about 80 plus. I'm going to stop talking and let's just listen to the QDrive and see what this spits out. So we're at, right around 77 decibels. We're at max speed. If we wanted to kick it down even, let's just take it down to a lower cycle rate, like 10 cycles a minute. Your sound decibels are going to drop off as well. At any time, you can stop the drive. So I'm just going to stop it. It's going to go into park. It's going to release the gas energy and shut down safely. Let's just start her back up. We're going to start up in 50 cycles a minute. So now if I wanted to stop it at any time or pause it at any time without venting, we can do that. Start back up. Stop. For whatever reason you wanted to. If there is any sort of emergency that you need to take care of, you can e-stop it at any time and it will shut down safely. That's it here. That pretty much wraps it up. Let's just start her back up. And thank you very much for joining today.
Thanks, Richard. Let's get back to Dave, who's going to talk about how gas cleanliness is maintained.
Thanks, Irma, and thanks, Rick, for the great demonstration. As I mentioned earlier, we can use the QDrive for handling high purity gases, and that's done by using what we call a distance piece, and that's the separation between our gas section and the servo drive itself. And this drawing here kind of shows you how that works. The left-hand side here represents the servo drive itself. This green would be the lubrication oil that's in the servo drive. We have several seals in there. We have 2 oil seals, and then we have an oil seal with a wiper right here is the blue line. This dotted line represents the piston rod itself. Then we have a couple of gas seals with a wiper seal in there also. And then this is our gas section. This is the gas, represents the gas piston with a seal on there. And this section right here would be our process gas. It might be something like helium or nitrogen. Behind this piston right here, we have a gas vent. So any gas that does leak across this, the seals on the piston will escape to atmosphere through this vent. Plus, there's a constant movement of air through this vent as the piston goes back and forth as the volume changes behind the piston. So there's air going in and out at all times. We have another vent right here in our distance piece. So if there is any gas that does get into this section right here, it will be vented out to atmosphere there. And then if any oil does get across the oil seals here, it will be collected in this oil drain, and there's a sensor here that will notify the control that there is oil where there shouldn't be. Also, if you do have a high high purity application, one thing we can do to help make it even cleaner in here is, instead of just having this vent here open to atmosphere, we can actually fill this vent with the same process gas that you're running over here. So that way we have both the same gas on both sides of the piston. So if there is any leakage, that will it'll be the same gas, so it won't affect the purity of the gas itself. And finally, the actual stroke length of the QDrive is 6.2 inches, but the distance from these seals to this seal is 6.58 inches. That's the last thing or the final thing that we do to help make sure that our gas stays as clean as possible.
Thanks, Dave. Now let's look at what else QDrive has to offer.
At Haskel, we understand how crucial controlling and monitoring compressor and system conditions during operation is. This is why we have created the QDrive gas compression system with a user-friendly HMI that enables robust monitoring and advanced control of the compressor and system conditions. Here's how the system works. First, you get access to an interface with QDrive that allows you to set different modes of operation, pressures, and cycle rates. For modes of operation, choose between compressor mode to maintain a constant process pressure, or between fill and pause or fill and stop for applications such as gas bottle filling. You also get to view indicators for the inlet pressure, inlet temperature to first compression, outlet temperature for second stage, heat exchanger interstage accumulator pressure, temperature leaving the second stage, and the outlet pressure. What's more, our HMI system allows you to set your output deadband, cycle rate, and target output pressure. We understand just how important safety is. This is why the system information page gives you a full overview of everything that's happening to help you maintain optimal temperatures and the target pressure. You can also check out all active alarms and the alarm history via the active alarm screen. Serviceability is important too. This is also why the HMI monitors running time and will notify you when spare parts are required and service is due, minimizing downtime. Don't wait. Add the power of controllability, connectivity, and serviceability with QDrive's powerful HMI system.
That's great. Now let's hand this over to Scott to find out more about QDrive's revolutionary benefits.
Thanks very much, Irma. Well, let me tell you, QDrive is smart. The process logic controller is built right in and provides infinite controllability, and you can make on-the-fly adjustments whenever you need to. QDrive handles all the venting, gas flow, and relief valve control, and can currently handle pressures up to 11,000 PSI. As we looked at in the video, you can program different modes of operation with the simple touch of a button. You can go to compressor mode, fill and pause mode, fill and stop, whichever one you need, QDrive can handle it. QDrive also lets you know when it's time to order parts, perform maintenance, and if operations start to deviate from normal. Once more, QDrive has remote capabilities, such as remote monitoring, predictive service and maintenance email notifications, and alerts and alarm and email notifications. Matter of fact, I have a few examples here to show you. Here's a screen here where the QDrive remote is showing you the inlet and outlet gas pressure, operation modes, the cycle rate, and the service due. Right now, it's showing you in pressure in bar and temperature in Celsius, but with a toggle of a switch down at the bottom there, you can switch it to PSI and Fahrenheit if you wish. This screen is depicting the pressure and temperature in graphical form. It lets you know what the inlet, outlet, and interstage pressures are, and it also lets you know the inlet, outlet, and coolant temperatures are. This is something you can do anywhere in the world. If you have a need to check on your system remotely, you can do it right here on this screen. And finally, this is a maintenance screen. This shows you, as you saw in the video, a couple of alarms that are listed there. It shows you the service due, and how many specific hours that will enable you to better plan your outages. And it also allows you to send these types of notifications for service and for alarms to other people. Say you're going on vacation and you're in charge of running the machine. Well, you can put someone else's email in here when you're gone, and they can take care of things for you. QDrive's also efficient. 95% power efficiency due to its permanent magnet motor technology and that direct drive. It has lower heat removal requirements compared to other technologies. And as Dave mentioned earlier, there's virtually no power required during idling, which translates into significant cost savings. There's also no need to unload the compressor and needless wasting of energy. You can start QDrive up at a wide range of pressures, and that could be significant cost savings to you, so you don't have to worry about drawing that pressure all the way down and restarting the system. Controllability means less need for buffer systems and downstream storage. And with a smaller amount of moving parts, performing maintenance is easy and quick. QDrive is also easily serviceable. There are very few moving parts, and the ingenious cabinet design makes changeouts effortless. The electric servo drive allows for longer run times between maintenance. The self-diagnostic software warns you in advance when it's time for service. You can count on QDrive to help you plan your downtime. Also, QDrive is quiet. OSHA requires noise abatement programs for equipment running at 85 decibels or higher. The QDrive runs at a max of 77. This means there's no noise abatement program needed. There's no extensive piping and wiring to remote areas of your facility because the QDrive doesn't need to be in a remote area of your facility. Production, flow, and pressure changes can be made right where production is happening, saving time, money, and manpower. And the QDrive can be used safely and effectively in laboratory settings, near offices, and in medical facilities. Once more, QDrive is clean and green. The low oil pressure for lubrication of the electric servo motor means little worry about medium contamination and potential for environmental issues due to leaks. QDrive doesn't rely on the facility's air compression system to boost the medium, thereby reducing the consumption of less green energy. There's also less worry about energy drops in the system because you don't have to rely on that air going through the system. I know there are a lot of companies out there that use a lot of shop air, and it can fluctuate from time to time, and that could cause a problem with your system, but not with the QDrive. QDrive also runs on clean energy. So if you have a solar bank or windmill for energy production at your facility, you can count on QDrive to run on it. Now, QDrive has been proven because we've had a couple of field beta tests done out there, and I'd like to talk to you about a couple of them. The first one is Cool Clean Technologies out of Eagan, Minnesota. They produce systems that blast components with dry ice particles for cleaning. Now, their application, they needed to boost CO2 vapor from 200 to 920 psi with flow rates up to about 100 standard cubic feet a minute. And what we did was we installed a QGD 150 in there last summer. How did the QDrive do? Well, we performed well, even though there were challenges. We did know that the cooling water that supplied to the system was too cold, so our team reconfigured the piping and using QDrive sensor array, supplied cooling to the motor on an as-needed basis. It made it a lot easier for us to do this as we had some issues with that cooling water being way too cold. So now we could pump it in when it was needed, and the system sensed it and sent it through. We also experienced some output pressure variations due to the site's piping infrastructure, but by updating the software and making use of the controllability, we were able to slow down QDrive's piston speed when we needed to allow for stable output pressure. We also had a beta test at a CO2 oil extraction system. They had been using a diaphragm compressor and were having a lot of difficulties with it, both on the maintenance side and operations. So this application was to boost CO2 vapor from 400 to 4,200 PSI with flow rates up to 112 standard cubic feet per minute. Well, how did QDrive do under these circumstances? Well, we did have some unforeseen obstacles once again that we had to overcome. QDrive needed to function as part of the customer's extraction PLC system. So what we did was we updated the programming to seamlessly talk to the customer's control system. So the QDrive system talked to the customer's PLC, and it worked out really well. With the recirculated CO2 varying in pressure, which can sometimes happen in oil extraction systems, we had to rewrite the software and change the stroke length when it was sensed that we were running out of force. This enabled the output flow rates to remain consistent. And once again, consistent outflow is what this customer wanted as well. So we had to make sure we were doing things the right way. Finally, the QDrive's cooling jackets prevented residual botanical oils found in recirculated CO2 from cooking in the system. This can sometimes happen with systems where the recirculated carbon dioxide will have some residual oil in it. But since our cooling jackets kept that QDrive nice and cold, the oils were simply carried out by the CO2. And finally, QDrive is proven and ready. QDrive is smart, and it's only getting smarter because of our learnings from these beta sites and from our rigorous durability testing. The high purity and oxygen versions of the QDrive are now available, and a hazardous gas version is on the horizon. So if you're interested in learning more, please give me a shout out on the email, scott.sopko@haskel.com. And I'd like to really thank you for joining us today. It was a pleasure to explore the QDrive with you. And now it's back to Irma.
Thanks, Scott. Thanks, Dave. Thanks, Rick, for all of that information. And now it's time to move on to Q&A. We've got a bunch of questions. They started coming in really early. So I just want to remind everybody that we're going to get to as many questions as we can now. And we will get back to everybody's question. If we miss your question on this live presentation, we'll get back to you personally within the next 24 hours. And then we'll put out an FAQ so that all attendees get to view all questions and answers, and that'll come in a post-webinar email. So without further ado, let's get started with our first question. Here's question number 1. What is availability? Can I buy one now? Scott, why don't you take this one?
Okay, I'll take this one. Well, the availability of a QDrive is right now. Once we review your requirements and find the model that best fits what your needs are, the lead time is about 8 weeks from issuance of a purchase order.
Okay, great. Next question. Will a technician come to our facility for startup? Dave, this one's for you.
Irma, the installation is actually quite simple on these. It's, as Rich kind of showed in the tour video that he did, it's just a matter of hooking power up to it and hooking the utilities up to it and the gas up to it, and and connecting it to what it's pressurizing, and it goes pretty well. We do have a variety of different startup packages available, which could be discussed specifically for each person's individual needs, though.
Okay. Question number 3. Can you use the QDrive for multiple gases? Dave?
I'm not sure. There's a couple ways I could answer this question. One is, could I run 2 different gases at the same time on the QDrive? Because it's double acting, we probably could arrange to run one gas through one side and one gas through the other side. with some caveats, it might be doable to do that. It could be doable to do that. Or if you're asking if today I could run helium and tomorrow I could run nitrogen, that wouldn't be a problem either. The seals that we use are compatible with most gases. The only concern I'd have would be if you ran some high purity gases one day, other days you ran gases that weren't as clean, it might leave the those not so clean gases might make it difficult to run high purity gases in the future. But in and of itself, the QDrive doesn't really care what gas is running through it.
Okay, next question. How long does it take to perform routine maintenance, and how long would my system be down? How about Rick?
Yeah, so routine maintenance, every 2,000 hours, you're going to want to change out the oil. And every 4,000 hours, you want to change out your piston seals in your gas sections. So the oil, you'll be down for roughly about 30 minutes. It's kind of like changing the oil in your car. What you'll do is you'll just open up the drain plug down there in the lubrication circuit during the tour. I think I went through that. And you'll open up the drain plug there, drain out the oil. About 20 liters will have to get refilled. You can get that oil from us over at Haskel. And you can use, actually, you can use the 3/4 horse pump to help you pump the oil right back into the drive. Now at 4,000 hours, again, you'll probably be down for another 30 minutes. This is going to change your piston seals out. You'll have to take off the, the handful of torque nuts on your end caps of your gas section, pop the end caps off, extract the piston, do your piston seal change where you'll take off a snap ring, replace it with the piston seals and the wear rings. Again, you can get that from us over at Haskel, and put it all back, torque down your tie rods to 200 foot-pounds for the particular gas section for that model, and you'll be back up and running.
Hey, Rick, isn't there a filter that has to be changed at that time also?
You're right. So for the oil, there's 2 filters. Those come off as well every 2,000 hours.
Okay, great. Now here's a question. I see it's actually come up several times here, so it's a good one. What's the price? Scott?
Oh, okay. Yep. Well, that is I guess a tricky question, because we have many different models and each customer has different requirements. So the price is going to vary. So what I would suggest doing is just get in touch with me about your specific requests, and what I'll do is I'll work with you and put a quote out to you.
Perfect, thanks. Okay, next question. How does the efficiency compare to diaphragm compressor? How about Dave?
Thanks, Irma. We don't have a lot of efficiency information on the diaphragm compressors. But what we can do is, if you contact us, we have a lot of information on the QDrive, and we can run your specific needs and come up with some pretty precise cost of operation calculations for you, which could be compared with the same cost of operation calculations for a diaphragm compressor.
Okay, next question. What are maintenance requirements and frequency? Rick?
Yeah, so maintenance requirements, kind of just like I previously stated in the other question there. Every 2,000 hours and 4,000 hours, you're going to be required at 2,000 hours to do your oil filters and your oil, about 20 liters of oil there. And every 4,000 hours, you'll do your oil again, and also your gas section piston seals.
Okay, good deal. Thanks, Rick. How about the next question here? Are there additional service fees for remote monitoring? Scott, I think this one's for you.
Yeah, the answer to that one is easy. No, all those remote monitoring capabilities that we showed you earlier in the presentation, they're all included as part of the QDrive package.
Great, thank you. Okay, Next question, where are these built? Dave.
Oh, the QDrive is built in the Burbank facility in Burbank, California, just outside of Los Angeles. Proud to say that.
Awesome. That's where we're broadcasting from live today. Okay, next question. Can you talk about safety features implemented? Rick, over to you.
Yeah, no problem. Yeah, the QDrive has quite a bit of safety features built into it, just from the mechanical side and also the controls. Just in the mechanical design of the entire system, all of our gas sections and tubing, just basically the whole system and the plumbing is all designed to, your 4-to-1 kind of ASME standards. And on the plumbing and instrumentation, all the proper relief valves are in there. Our interstage vessels, everything's PED certified, and our relief valves as well. Now, yeah, and then the gas sections, everything's designed to the 4-to-1 ultimate tensile strength on everything. Now on the control side, we have a whole array of instrumentation already adapted to the machine. That's your pressure sensors, your temperature sensors, and basically each model is designed in the controls to stop at those given pressures for that given model. And after that, it's just kind of just plug and play at that point. So what you'll do is you'll just set up the drive to have the proper inputs you want for your maximum pressure. You can go all the way up to the maximum operating pressure for that particular model. You could set your particular temperatures that you might want downstream for your gas. That could also aid in your application. And the QDrive will just take those inputs from you that you'll be using on the user interface, and you just press start. And at that point, the QDrive will run, abide by those thresholds. And if anything starts to get too close to your maximum thresholds or minimum thresholds, like your minimum amount of inlet gas you might want to put in there, you'll have a automatic notification sent to you where you can set up in your remote interface. So that's where you can put in your email, you can put in your phone number, you can get the text message. And so you'll be alerted whether you're offsite or if you are local, you'll be able to see indicators there on the machine. Also, another kind of redundant feature you could have in here is the QDrive has the ability to communicate to your facility's controls. We can send indicators downstream to you, and you can send controls back to the QDrive. So that can get set up for you at your facility site.
Thanks, Rick. Okay, looks like we have time for one more question here. Let's see here. Can the QDrive be placed outside? Dave.
As long as it's protected from the elements, it can be placed outside, but it does need to be protected from the elements. Although I think it would be a good idea to review your location with your salesperson just to make sure that it's going to be okay for that specific application. It's not designed specifically to be used outdoors, but as long as it's protected, it should be okay. We are developing a hazardous environment version of the QDrive, and that one will be rated for outdoor service. But the current one, probably as long as it's protected.
Thanks, Dave. Okay, folks, looks like we're out of time now. So if we didn't get to your question today, we will reach out to you directly with an answer to your question within 24 hours. And we'll put together an FAQ sheet covering questions and answers, which we will share with you in a post-webinar email. We'll also provide you with the link to the webinar so that you can view it again and you can share it. And in the meantime, if you have any more questions you may have not gone to ask, you can always reach out to Dave and Scott. We've got their contact information up in the screen, and you'll receive it again in the post-webinar email. So I want to thank everybody again for attending. Have a great day.